having branches. You're always going to begin with a tree and then you have branches after that in order to see how the tree is going to emerge. But like I said, let's first of all look at the first 3 bullet points, these ones. We are told that machine A produces 20%. I prefer writing those as decimals. But before we get there, I want you to pay attention to the fact that of all the production that we're talking about, we always have to end up with 100% of the stuff that that particular company is producing. It doesn't matter how many units they are producing, but if you give me the production in percentage terms, it has to be 100% in total, right? Now, why am I mentioning this? You might find yourself in a position where they do not say anything about machine C. So if I was not told what the value of this percentage is, I was going to be able to figure it out because we already know that we are dealing with 3 machines, A, B, and C. If the first 2 combined produced a total of 20 and 30, which is equivalent to 50, I'm expecting the last machine to also produce 50% so that the total percentage of production amounts to 100%. I'm just mentioning that by the way, because I know we were told all the percentages, but in future, in case they don't say anything about C, you could find it by paying attention to the fact that all the production combined has to be 100. So if I already know 2 of them, I can figure out what the third machine is going to produce in percentage terms. But like I said, I want to actually put more information here so that we'll see what is going on, and I want to rewrite this information in decimals. So 20% literally implies 0.2. For machine B, it implies we've got 0.3. And for machine C, it implies that we've got 0.5. When you add all those, they actually equal to 1. Right. Now, if we want to draw a tree diagram, we obviously have to start with the seed. All trees start with the seed. So I'm going to plant my seed on the far left. There's my seed for this particular tree. Let me just see that I have enough space so that I utilize all the space that we have here, right? We're going to write this on a tree diagram. So let me just utilize all the space that we were given here, which is nice and enough. So there's my seed I've planted on the far left. Now, we want to represent this information on a tree diagram. The first branches that I'm going to have are obviously going to be the total production because of machine A, and the next branch is going to be for the production of machine B, and the last one is going to be because of the production of machine C. Now, we know that each machine is not perfect. Why? Because they did mention here, for example, in that bullet point that 2% of what is produced by machine A is not perfect, right? So that means from machine A, I might have 2 cases. Case number 1 is a situation where what I've produced is perfect. If what I've produced is not perfect, then we're going to write it as not perfect. And this information was given to us even here in the opening statement. They did say that if a particular copy is not perfect, you can write it as NP to denote not perfect. The same story also applies for machine B. Machine B makes copies. We know that it makes 30% of the copies. Now, some of those copies are going to be perfect, some of them are not going to be perfect. So I'm going to denote that by saying some production from B is going to be perfect, some production from B is going to be not perfect. Okay? Right. Now, the last thing here is for machine C. Again, once more, machine C production can be perfect, and machine C's production can also be not so perfect. Right. So when you do your trees, always have these in mind. You just put all those possible outcomes that you can get from each one of your machines. Then there are 2 things that you have to add. You can combine them or separate them, right? I'm going to separate them for the sake of your education so that you can always remember what is going on when you have here. So what I'm going to have here is what I want to call outcomes. What are possible outcomes? What can happen if I am making a copy in this company? If I'm producing something in this company, what can happen? Remember, you can use machine A and get a copy that is perfect. You can use machine A and get a copy that is not perfect. You can use machine B and get a copy that is perfect, or you can use machine B and get a copy that is not perfect. So all those outcomes, I'm going to write them under the outcomes. And then when I'm done with that, I'm going to find the numerical probability that I'm going to get a particular outcome, right? So that's going to be probability, the probability that I'm going to get a particular outcome. So now the first possible outcome is going to be, we are using machine A and we get a copy that is perfect. So I'm going to write that as A and P. That means I used machine A and I got a copy that is perfect. If that is not the case, I might get machine A and end up with a copy that is not perfect, which means I'll use machine A, but my copy is not going to be perfect. If that's not what I'm going to get, I might obviously use machine B, end up with a copy that is perfect, B perfect, or use machine B and end up with a copy that is not perfect. Or I might use machine C and get a copy that is perfect, or use machine C and get a copy that is not perfect. So those are the possible outcomes: A perfect or A not perfect. You might get B and then you end up with a perfect copy, or you use B and end up with a copy that is not so perfect. And the same applies, of course, when you're working with C. Now, what is the probability that I'm going to use machine A and I'm going to end up with a copy that is perfect? So you need the probability values on the branches of your tree. And remember, when you add all the values that you have here, all the probability values, they need to always amount to 1. So each branches that you have that emerge from each node must always add up to a probability value of 1, because total probability can always only sum up to 1, right? Now let's go back and find all those probability values we were given and write them on the branches of our tree. We were told that machine A gets 20% production, B 30, and C 50. So let's write those values as decimals. So that means here I'm going to have 20%, that's going to be 0.2, 30%, that's going to be 0.3 for B, and then for C, I'm obviously going to have 0.5 as the probability that a machine C is going to be used. Now, in the case of A, now this is where it becomes more interesting. We were only informed about copies that are not perfect, and they said to us 2% of the copies produced by machine A are not perfect. Now, obviously, if I may just zoom on that, let's take this and analyze it here. So, if you tell me that 2% is not perfect, if 2% is not perfect, then we can conclude that 98% is going to be perfect, right? Those are the only possible outcomes that you can get in the case of A. So what I'm going to write on my branches, I'm going to write, okay, if we are dealing with machine A, we know that the copies that are not going to be perfect are 2%, and 2% as a decimal is 0.02. Now, if 0.02 is not perfect, that means that the perfect ones are going to simply be 0.98. When you add 0.98 and that 0.02, you must end up, of course, with that answer of 100. Of course, the sum of those must end up to 100. So be careful of how you actually working with this. So 0.98 plus 0.02 does give you a value of 1, which is the total possible probability of achieving something out of that outcome. Same applies for B. I'm going to be a little bit quicker now because you guys can see what is going on. What was the story with machine B? We were told that for machine B, in the case of machine B, 3% of what is produced by machine B is not going to be perfect. So if we write that as a decimal, we're going to obviously have 0.03 as not perfect. That means 97%. If 3% is not perfect, 97% is going to be perfect, and that as a decimal is going to be 0.97, right? And then the same applies for machine C. We know that 8% of what is produced by machine C is not perfect. So if 8% is not perfect, 8% is going to be 0.08, therefore 0.92 is going to end up being what we get as perfect copies from machine C. Now, in order to get the values, the probability values for each one of those possible outcomes, I'm going to have to multiply the values of the probabilities on the branches. Why? Because it is the story of AND. For example, in the first case, I am using machine A and I get a perfect copy. So that means the probability solution for that, the product of that, is going to be that 0.2 multiplied by 0.98. And then it's going to give us the probability value, which is going to be something very interesting. Okay, obviously going to use our calculator in order to figure out what the answer to that is going to be. And then if you go to B, let's just get it quickly and see what the answer is going to be. When you multiply that 0.2 with 0.92, what you end up not 92 but 98, backspace there. 0.2 times 0.98, we end up with an answer of exactly 0.196. Okay, so 0.196 is the probability that we use machine A and we end up with a perfect copy. Okay, Let me remove that equality sign to minimize confusion. There's nothing wrong with having it. You can have an arrow there to show where this is going. You can have that as a product without the equality sign, or with the equality sign. It doesn't make any difference. Now, the second product is going to be the one of using machine A and getting a result that is not perfect. You take the 0.2 from machine A, you multiply it with 0.02 from the fact that it's not perfect, and the product of that is going to be something very interesting as well. Let's get the answer to this one. It's going to be 0.2. We are multiplying that with 0.02. The answer that we end up with here is something pretty basic, which is not 4. Okay, so 0.004 is the value that we end up with. We're going to have to obviously proceed with the same argument. Using B, getting a perfect copy will be the value of the probability alongside the branch of B. Okay, so you take that 0.3, you just multiply it with that 0.97. You're going to end up with the answer that you'll have here. So 0.3 multiplied by 0.97. What do you end up with? Let's just see what the answer is going to be for that one. Okay, so 0.3 and 0.97. That's 97% and 3%, 30% I mean, and that gives you an awesome number of 0.291. Okay, so 0.291. Okay, and then for the next one, 0.3 multiplied by 0.03. Okay, 0.3 multiplied by 0.03. The product of that is going to give us something pretty basic. Let's just see what the answer is going to be here. I think it's going to be 0.091, 009, and then we're obviously going to have the next one for C and perfect. That's going to be 0.5 multiplied by 0.92. If you multiply those two, you end up with 0.46. Okay, obviously you can always confirm to make sure that you're not making a mistake, because when you're using your calculator, you get much more accurate results. So that's 50% multiplied by 0.92. Do we end up with 0.46? Yes, we do end up with 0.46. And obviously the last one is going to be what you get when you multiply 0.5 times 0.08, 0.08, and we end up with an answer of 0.04. Okay, cool. So this one is going to end up as 0.04, and that is coming from the product of a half of 0.08. It does make sense that it's actually 0.04. So this would be a complete tree, beautiful people. It's a complete tree with all the branches. It has all possible outcomes, and it has probability values. So these are your branches. These are possible outcomes that you may get. It may be A perfect, it may be A not perfect, it may be B perfect, B not perfect, etc. So if we're asking for probabilities, the answer is always going to be these numbers that you have here. These products that you have at the end denote the total probability. And when you add all of them up, they must always sum up to an answer of 1. Be careful of that. Right, so that's my tree diagram. I'm happy with that. Follow-up question says a banner is selected at random from the total production. So we want to calculate the probabilities here. Let's see what the first question asks. It says, calculate the probability that the banner selected at random was produced by machine B and not perfect. So watch this. That's machine B and not perfect. So what exactly am I looking for? I'm looking for B, and it must not be perfect. So you go back to the tree and you try to read off this answer, right? Let's try and see what is going to happen here. So B is here and B not perfect is here, okay? So B not perfect is going to be 0.3 multiplied by 0.03, which gives us at 0.009. So the answer to this question is pretty basic. We already have the answer. We can read off from our tree the probability that you're going to use machine B, and then you're going to end up with a banner that is not perfect. B and not perfect, right? You can write it this way, or let me just write it explicitly for the sake of education. We want to emphasize on notation. So I'll use the mathematical symbol for and that we use. B and, okay? We're using B and the copy comes out not perfect. What's the answer going to be? It's obviously going to be that 0.009 that I told you about, because we are able to read it from our tree. It's 0.3 B and not perfect. We end up with a probability of 0.009. Okay, the last question on our beautiful tree is asking us to calculate the probability that the banner selected at random is not perfect. They're not saying much. The only thing they're saying is we are looking for a machine that is not perfect. So all you're looking for is anywhere where it reads not perfect. Okay, that's what we're looking for. So go to your tree, look on the outcomes, find all the places where we've got outcomes that are not perfect, irrespective of whether it's coming from machine A, machine B, or machine C. Mathematically speaking, before I read off my answers, I could say the probability that we end up with something that is not perfect could be the time where we are reading it from A, which means the probability that you are reading it from A and it is not perfect. Let me just remove that and put A, because I want to specify that we might find an imperfect copy using machine A. So it could be in machine A and it is not perfect, or it could be the machine B and not perfect, or you can get it from using machine C and you end up with a copy that is not perfect. Now that plus, that or is basically synonymous with addition, right? When you see the word or, it's something or something else. It means it's the probability of the first case plus the probability of the second case. So we're going to add all the probabilities that we ended up with in our tree when we were looking at these three outcomes. So that means our answer is going to be what you have here plus what you have here plus what you have here. Let's see them and write them down. The first one of not is going to definitely be what we are reading off from A not perfect, which is not 0.004. Okay, so that's 0.004. Yes, so not 0.004 plus the one of B and not perfect. We already have it from above. It was not 0.009. And the last one from C and not perfect, that's going to see what C and not perfect is going to be. Remember, like I said, we're just reading where it's not perfect, irrespective of which machine is this coming from. So from C, it's just going to be 0.04. Okay, so 0.04 is going to be the last value that we have here. And then when you add all those up, you must end up with something that is pretty awesome. Let's call our calculator and find out what it's going to say to us. So we are interested in adding 0.004 with 0.009. We also want to add that to 0.04. What do we end up with? We end up with 53/1000, which in decimals is actually 0.053. And as a percentage, if you are interested in writing the number as a percentage, it's just going to be 1, 2. That's basically 5.3%. So it means on average, this company produces about 5.3% of defective penners. So they produce penners, they print penners that are perfect 5.3% of the time, which is basically a very good production if you ask me about it. So this is actually a very awesome question that gives you an understanding of how do you analyze the tree diagram. Make sure you've got your branches. You always have those branches branching from the seed. And then if you've got any outcomes that are depending on the previous ones, like in this case, we either use machine A, machine B, or machine C. And if we're using any of those machines, we might get a copy that is perfect or not perfect. For machine B is also perfect or not perfect, etc. Once you've got all those out, make sure that you write the possible outcomes, list them, and then find the probabilities by multiplying the values on the branches of your tree, and then everything else should be perfect. If anybody asks you about A perfect, you just read it from the tree. If they ask about A only, you read all the A's that appear in your possible outcomes. In this case, they wanted those banners that are not going to be perfect, irrespective of what machine you're using. So you find in all your outcomes where is not perfect found. Once you have that, then you have your answer. You add all of that because it's either going to be through machine A or machine B or machine C, and or is synonymous with addition. So thanks for that question. We're coming back with a whole lot more. Don't go anywhere. We'll be right back.
No one ever asks why we do the weird things we do. Like, why once is never enough. Or doing 2 trips is just one too many. Why do we, before we use these, or say 5 when we mean 20, why do we have second thoughts? And think that lift buttons make them go faster? Why don't we walk there, cross our fingers, touch wood, and struggle to hide our true feelings? At Liberty, we want to know all the weird and wonderful things that make us human. Because human beings, being human, are what we make financial solutions for. Liberty. In it with you.
Did you know that there is a country where the roads are made of coral? The country is Guam, and because it doesn't have any natural sand, the island nation makes its asphalt using a mixture of ground coral and oil rather than importing sand. When it gets wet, the oil tends to float to the surface of the roads, making them dangerous. This is one of the reasons the speed limit on most of the island is only 55 kilometers per hour.
Welcome back Tenfolders to Tenfold Live, a show that is proudly brought to you with lots of love by Liberty. A very special shout out always goes out to Liberty for giving us the opportunity, guys, to share all this awesome content that we're sharing with you. Remember, guys, if you haven't, just go to your app store and look for what we call the Tenfold Education app. It's an awesome app packed with a whole lot of very awesome resources that will help you build your content. It's got theory videos that help you understand where the concepts that we're using here come from and how to actually work with them in application processes. In addition to that, perhaps you want resources that will help you, just go to WhatsApp. Go to WhatsApp and send us a greeting. There's decks with a lot of past papers that will help you also, because we know you need a lot of practice considering the fact that exams are coming up next. So you do want to make sure that you don't miss any of this stuff that we have here just for you, because we love you. We love you tenfold, so we want you guys to benefit all the way. Okay, cool. Beyond that, we have videos also, guys, on YouTube. So just go to the Mindset Learn channel, look for our YouTube channel there. It's called Mindset Learn. Like the videos, share them with your friends. They're based on all the concepts we've done in all our previous shows and a lot more. So you do want to make sure that you don't miss any of that. I promise you, if you keep watching these videos, you're going to learn more. On today's program, we are looking at probability and counting principle, a very challenging concept because it's based on weight problems, but because you're watching Tenfold Live, you probably have your own questions wherever you are. We encourage you guys to send them through to us by either using the app. If you don't want to use the app, you can also go to our Facebook page and load them there. Please bring them on. I know there's something that you have always been wondering where you'll get answers from. Maybe it's something that is based on probability or counting principles. We're here for you. Send them on on our Facebook, also on our Facebook page. We'll get those questions and help you understand how to work with them. But then these ones that we're going to be looking at now include the ones that you sent to us already. And our next question is the one that was sent to us by Ino. It's an awesome question based on a Venn diagram. You don't want to miss any of that. Let's jump right into it and see what this question is actually all about. All right, so it is question 10, and it reads as follows. It says, a survey was conducted amongst 100 grade 12 learners about their use of Instagram, Twitter, and WhatsApp on their cell phones. The survey received the following, okay? 8 use all three, 12 use Instagram and Twitter, 5 use Twitter and WhatsApp, but not Instagram. X learners use Instagram and WhatsApp, but not Twitter. 61 use Instagram. 19 use Twitter. 73 use WhatsApp. And 14 use none of these applications. Hopefully, all these 100 grade 12 learners use the Tenfold Education app. I'm hoping that they are using Tenfold Education app since they're not using all these other apps. Okay, cool. So let's see what the first question is asking us. You can clearly tell that this is going to be a Venn diagram situation. Oh, there we go. Even the first question does say that. It says to us, draw a Venn diagram to illustrate the information above. Okay, so if I am interested in drawing a Venn diagram, you guys need to remember what a Venn diagram looks like. I don't know if I can get a nice, beautiful rectangle here from my resources so that you guys will see the beauty that we have when we are dealing with a Venn diagram, right? A Venn diagram is always denoted by a huge rectangle, and this rectangle is obviously going to have circles inside. So don't disappoint me. Okay, it's disappointing me with color. I'm going to draw it with my own handwriting because I am that ghetto. All right. So let's just go and do a beautiful rectangle. That's your rectangle for your Venn diagram. You're obviously going to use a much more better resource. I'm old-fashioned. Okay, and then on top here, you're going to obviously put the total sample space of how many people are going to appear in your Venn diagram. We use circles to indicate all those possible outcomes that you're going to work with. We were told in the opening statement that we've got 100 learners that participated in this survey, right? Now, in this case, we've got three things that we are looking at. We're looking at WhatsApp, Twitter, and Instagram. And I want to represent these using just letters. For example, I'm going to call Twitter T, okay? And I'm going to call Instagram I, and I'm going to call WhatsApp W, okay? Just be wary of that. Sometimes if we are nice, we let you know that please use W for WhatsApp, please use I for Instagram, please use T for Twitter. If we don't tell you, you can just ask us to allow you to do that. You don't have to write them in full. If you don't mention it, we're still going to be able to see what you're doing. We are not old-fashioned. We can see what is happening here. Okay, cool. So what we're going to have now is circles, right, to represent each one of those possible outcomes. Now, because of the fact that we've got this statement, pay attention to the following. There's a statement in our opening love letter that says 8 uses all 3. So because of this first opening bullet point here, I know for a fact that I'm going to have 3 circles that intersect at some point. There's going to be a 3-circle intersection at some point because of that statement, okay? Now try to draw these things big. Don't be stingy with the space and draw tiny rectangles. Draw them big to fill the entire page if you have to, so that you have enough information to look at and be able to see what is going on. If you draw tiny drawings, you're not going to go far with what you're working with. In fact, the rule of thumb that I want to encourage you to work with is the following. If you have to draw a diagram, whether it's a graph or any other thing, it must be the size of your hand. If it's the size of your hand, it's good. The worst you can do is maybe the size of your palm. That will be good enough. Don't draw tiny drawings because then you have to read from them and it shows that you're not confident with what you're doing and you will even struggle to see what is going on. You want to draw it nice and big as you can, and then be able to see what is going on there, like I'm going to do now. Okay, so here's my first circle. This one is going to be the first circle, okay? And then I'm going to have the second circle, all right? And I'll have my last circle here at the bottom. 3 circles. Let's name them. WhatsApp, Twitter, Instagram. So the bottom circle represents Instagram. This circle represents Twitter. And the first one represents all the learners that use WhatsApp. So now we're going to try and fill the information in here. We know there's 100 of them in total. But let's look at the love letters, the bullet points from our love letter, one after the other. The first one says 8 use all 3. So 8 learners use all 3 apps, okay? So it means in my tree, right in the triple intersection, I'm going to have the number 8 because that number is the kids who are doing WhatsApp who are also on Twitter and Instagram at the same time. So that's in fact where you always begin, irrespective of how the bullet points were lined up in the opening statement. Start with the triple intersection, and then you go to these double intersections here, and then end up with the single intersections. What we're going to have here is all the kids that are doing WhatsApp only. What we have here is all the kids that are doing Twitter only. What we have here is going to be Instagram only. What you have here is going to be those who are doing Twitter and Instagram, but not WhatsApp. Look at this, is not including WhatsApp. So the people I'm going to put here should be the kids that are just on Twitter and Instagram, but not WhatsApp. Similarly, the kids I'm going to put here are those that are doing WhatsApp and Twitter, but not Instagram. Notice that I'm excluding Instagram. I'm just focusing on WhatsApp and Twitter. So I'm going to write them here. Okay, I'm just going to put them there. Now, what I'm going to write at the bottom left in this little space here is going to be all the kids that are on WhatsApp and Twitter, those who share those 2 apps, but not Instagram, not Twitter, I mean. Those that are going to be those that are on WhatsApp and Instagram. I'm going to write them here. Just be careful with that. Start with the triple intersection, go to the double intersections, and then end up with the single ones. And then after that, you can put the ones that are outside. It's up to you how you want to put them. You can put them now or later, depending on whether they were given to you or not. Okay, bullet point number 1, done. Second bullet point says 12, use Instagram and Twitter. Now, this is very interesting. I want us to look at that. Let's look at those kids. They said we've got 12 kids that are doing Instagram and Twitter. Now, if I come here, right, it's Instagram and Twitter. So the I and the T should be 12. So if I go to I and T and I put 12, it's going to be a terrible mistake. That's a mistake. Why? Because if you just focus on the Twitter circle, let's just zoom in on the Twitter circle. Here's the Twitter circle, right? And here's the Instagram circle. Now, if I'm just focusing on the Instagram and the Twitter circle, they meet each other right there in the middle. The examiner just told me that I need to have only 12 people that are on both Instagram and Twitter. They didn't say anything about those kids doing something else. The statement just says specifically 12 use Instagram and Twitter. They could be using something else, okay? So if I put 12 there, I need to have 12 as the intersection of Twitter and Instagram. But if I do what we have here as a 12, it means now I'm no longer looking at 12. I'm now looking at 20 kids that are on Instagram and Twitter, because it will be this 12 and this 8 that I've already written down, which will make it 20 in total, and that will be a big mistake. So what you need to do is notice the fact that we now need to start engaging subtraction. If I need to have 12 people between Twitter and Instagram, that means since I already have 8, I'm now just short of 4 people to put here. So that when you add the 4 and the 8 in total, you end up with that 12 that we have as the intersection for Twitter and Instagram. Beautiful stuff. Right. The next bullet point, which is bullet point number 3, says to us 5. Use Twitter and Instagram, Twitter and WhatsApp, but not Instagram. Okay, let me remove the I's and the T's so that we all see what is going on here. Right. So pay attention to this. We're now saying to you, we want 5 kids. And these 5 kids are on Twitter and Instagram, Twitter and WhatsApp, but not Instagram. So that means when I look at those intersections, right? When I look at those intersections, we do have where we have WhatsApp and where we have Twitter, right? Now, there is that circle. I'm going to draw it with a different color so that you see that we don't want it. This extra circle here for Twitter, we don't want to look into that, right? We just want to talk about WhatsApp and, okay, I just swapped them. What are they saying? It's Twitter and WhatsApp. So WhatsApp and Twitter are the ones that are on top. Let me just rephrase that, because I want you guys to see how the subtraction works and when do you have to subtract and when you're not supposed to subtract. I must account for 5 people, right? I want to account for 5 people that are on WhatsApp. They must be on WhatsApp and they must also be on Twitter, but not on what? But not on Instagram. So I don't want to include Instagram. Now you'll notice that if I add these ones here that are on the triple intersection, those 8 that are there, those ones are inside the Instagram circle, and I don't want to talk about them. I'm only interested in the W and the T. And the W and the T is only happening where? It's only happening here and nowhere else. So that's where the 5 is going to go. Once you add that blue dot that you have there, you're now adding people that are inside the Instagram circle as well. So that means we can take that 5 and write it as a value without any concern. Exactly here. Those people that you see there are on Twitter and WhatsApp, but not inside the Instagram circle. Oh, this is awesome. Okay, now we're told that X use Instagram and WhatsApp, but not Twitter. Once more, for that person who is probably asking from Wamklabeling and is probably asking, can you please repeat that? Here's a beautiful, beautiful question here, or the bullet point that we have now that is saying X use Instagram and WhatsApp, but not Twitter. So I am interested in writing the kids that are inside the Instagram and the WhatsApp circle. We've got the WhatsApp circle here. We've got the Instagram circle here at the bottom. So we want to put how many kids? We want to put X kids in that space. But we need to exclude Twitter. So that means I don't want those kids to be in this circle. So that triple intersection there, I'm not going to talk about it. So that means I'm only interested in this little space there that excludes the circle that has something to do with Twitter. That means my X is going to go directly there as the total number of kids that are on both WhatsApp and Instagram, but excluding Twitter. So be careful of that. Don't make these mistakes, guys. You need to know when to subtract and when not to subtract. Awesome stuff. So I'm going to have X here. Okay, so let's go to the next bullet point. What's the next bullet point? Our Venn diagram is coming up nicely. We now know that there are 61 kids who use Instagram. We've got 61 kids in total that should be inside the Instagram circle. Okay, let me remove this stuff. We have used this to explain to you what is going on, and I'm actually hoping that you guys can see what is happening. We're all happy with that. Right, so the question now says there are 61 kids that use Instagram. Now, we go to the Instagram circle, right? Find Instagram, write down 61. So if you go to 61 to Instagram, which is right at the bottom circle, and you write 61 here, that will be a mistake. Why? Because if you now zoom in on that circle, there's a lot of kids that you have inside the Instagram circle. You already have 61. If you write 61, you already have 8 here and you've got 4. And then you've got X also. Now you're adding 61. It means the total number of the kids inside the Instagram circle will now be more than 61. Unless if the statement said, those who are doing Insta only are 61. Then we could put this 61 here without any concern. But they didn't use the word only. The key word is the word only. If they say only, then you can put 61 here. But they didn't say that. That means all the numbers inside the Instagram circle need to end up or add up to 61. So this would be a terrible mistake. So what we need to do is just go back to the calculator and say we need to have 61 people. If we remove this 4 and we remove this 8 and we remove this X, how many kids will remain that are doing Instagram only? Okay, cool. So calculator back. We want to talk about 61 people inside the Instagram circle. We have already written down the 8 from the triple intersection. We have already written the 4 from the other side. We have left with X, which we can't subtract, of course. So what we have here is 49. That means this is going to be 49 take away X. We have that 49. We still need to take away X because we don't know. When you add all those values, I promise you 49 minus X plus 4 plus 8 plus X will give you that 61 that examiner is talking about. Next bullet point says 19 use Twitter. 19 use Twitter. I can't write 19 on the Twitter circle because we already have 5, 8, and 4 kids there. So out of that 19 that we're interested in, okay, let's put them down. 19 people use Twitter. Let's take away the 5 that we have already accounted for that are doing WhatsApp and Twitter only. We also need to take away, which kids are we taking away? We have to take away the 8 that are doing all 3. We also have to take away the 4 that are doing Twitter and Instagram. What do you end up with? You end up with only 2 kids that are just doing Twitter and nothing else. Those are the kids that are on Twitter and nothing else. Of course, we're hoping that they also have the Tenfold WhatsApp. They're not the Tenfold WhatsApp, but the Tenfold app, the Tenfold education app. Download that app, guys. Download it. Okay, cool. So you'll see when you add all the numbers inside that Twitter circle, when you add all of them up, they must amount to 19 because they did say that 19 people use Twitter. So we go to WhatsApp. 73 use WhatsApp using the same principle. 73 learners use WhatsApp. So let's go and say on the WhatsApp circle, we need to have 73 in total. We need to find 73 in total for those kids that are inside that circle. So let's call the calculator and try to do the subtraction quickly. So out of 73, remove the 5 that we already wrote. All right. Remove the 8 that we already wrote. We want to remove the X, but we must remove the X from what we have in front of us. We have 60. So out of that 60, we still need to remove X. So if I go back and I just say, okay, we're left with 60, we still need to subtract X. It's just we don't know what that X is, so we can't remove it. That's why we end up with just 60 minus X as the value under those that are doing WhatsApp only. Right. Then the last one says there's 14 that use none of these apps. Okay, 14, those will be the kids that are outside, obviously. 14 use nothing. Okay, cool. So that's a complete Venn diagram if you have to draw a Venn diagram. And I promise you, this is actually a very simple concept as long as you understand what is what. If you ask you for Twitter, it's everything inside the Twitter circle. If they ask for Twitter only, that will be the 2 that you see inside the Twitter circle. Next question asks us to calculate the value of X. Now, how do you work out the solution to this? It's pretty basic. When you add all the kids inside this rectangle, they must amount to the sample space that you have, which is 100 in the top right corner. So all these numbers, when you add them all up, we're going to end up with the number 100. So what do we know? I'm going to actually sum this up, guys. I hope you're going to see what is going on. When you add all those numbers that you see inside the circles, you must end up with the number 100. So already inside the Twitter circle, we know that we've got 19. The 4 and the 8, the 2, the 4, and the 5 amounts to 19. So I'm going to cheat this. I'm not really cheating it. It's just being smart about it. So let's see what will happen. So I've got those 19 from the Twitter circle, plus, after that 19 from the Twitter circle, the people that I haven't accounted for are these ones here, and those ones that you've got at the top. The 5, the 8, the 4, and the 2, I added them all. They gave me the number 19 that you've got at the bottom here. Okay, who must I add now? I must add this 60 minus x. So there's also 60 minus x, and then I must also add this x here, these, and then I must also add these kids here, which is 49 minus x, and then I must add those ones that are not doing anything, which is 14. All the numbers that you've got inside your Venn diagram must always amount to the total of the sample space, which is 100. They gave it to us, and we wrote it at the top right corner there. Okay, so let's see what the math says to us. The math says x will subtract x off, x and x will give you 0. Okay, and on the left-hand side, when I add all those numbers, let's just see what they amount to. I want the sum of 19, right, and 60. Okay, 19 plus 60. I also need to add 49. We're adding 49. I also want to add 14. So 19, 60, 49, and 14. Those are the numbers that I've got. There's 4 of them in total, the sum of which amounts to 142. So I'm now left with 142. Okay, there's one x still lingering there. Minus x must give me a value of 100. With basic arithmetics, you add x on both sides, and then you subtract 100 on both sides. You're going to end up with an x value of exactly 142 minus 100, which leaves you with 42 kids. Once you've got those 42 kids, they don't ask you to do it. You can do it for fun. You can obviously update your Venn diagram. 42 is the answer for x. If I ever want to go back to my Venn diagram and update it, it means I'm going to write it in blue. I'll have 42 as the value of x here. I've got 49 minus 42. That's going to give me 7 kids here. I've got 60 minus 42, the answer of which is going to be something beautiful. Make sure you're not making any mistakes. If you subtract there, you're going to end up with 18 kids that are here. There's 18 right there. Okay? You've got the total answers that you have. And you can even use those blue numbers to check if this satisfies any of the information that was given to you. For example, if I just go back and I try to add all the kids that are inside the WhatsApp circle, I will have the blue 18 I wrote. I will have the 42 that I wrote inside the WhatsApp circle. I will have the 8 in the triple intersection, and I will have the 5. Those are all the numbers that are inside the WhatsApp circle, the answer of which amounts to 73. Does this make sense? Yes, it makes sense. It means I'm correct, because if you go back, you'll see that they did mention that the kids that are on WhatsApp amount to 73 in total. So it means everything is actually working quite well. All right, so let's go to the last question. They say calculate the probability that a learner chosen randomly uses only one, not more than that. Only one. So we're looking for only one. Where is only one going to be? Right, so the probability that the kid does only one is going to be everywhere where there's a kid who's doing one. So look for the kids that are doing exactly one. We can't take the 8 in the middle. Those are on 3 social networks. We can't take the 5. Those are on 2 social networks. We can't take the 4. They are on 2 social networks. We can't even take the 42. We have to take the 18. They do only WhatsApp. We take the 2. They're only doing Twitter. We take the 7. They're only doing Instagram. So 18 add with 2, that's 20, and add with 7. That's going to give us an answer of 27. So it's the 18, the 2, and the 7 over a total. So that's actually 27 over 100. So which means you can leave it as that, or you can be taking it to 0.27, or you can even call it 27% of the kids in this particular school are in this particular network. So that's an awesome question. Thank you very much for sending it through. So we're going to go to our next question. It's a very, very beautiful question that is based on a Venn diagram. And if you think about it, it's actually not a bad question. It's very simple and basic. I want you guys to always know how to work with these kinds of questions without any challenges. We're now going to go to our next question. And this one is based on counting principle. Let's just see, because you have to always see how do you work with counting principles when you have these kinds of questions. They're very basic, but they're actually interesting, because in grade 12, this is specifically what we always push you to learn how to work with. So do make sure that you understand what is going on when you have questions that are based on counting principle. This one says, Lwazi and Ngwenga are the head boy and head girl of their school respectively. In addition, there are 3 boys and 2 girls who are prefects. They're all supposed to sit for 2 photos. In the first photo, order is not important. In how many ways can they sit? So the process of answering this kind of a question is pretty basic. Always set yourself, I don't like formulas, so I wouldn't encourage you to use a formula. Just set yourself up for 7 spaces. 1, 2, 3, 4, 5, 6, 7. We need to seat people here. Now, always ask yourself this question. In how many ways can I fill a particular slot? Now, why did I set up myself for 7 spaces? It's because I've got, if you look here, 3 boys, 2 girls, that's 5 learners. If you add Lwazi and Ngwenga, that makes it 7 learners in total. So if you're not telling me who I must sit first, it means I have got 7 people that I can select from to decide who I am going to put in the first position. So this first slot can be filled in 7 different ways. Times. Once I've put 1 kid to sit in the first seat, I'm left with 6 kids, and nobody's telling me anything about who must sit next. So that simply means that in the second slot, I can select amongst 6 kids who I want to sit there. So I'm going to have 6 possible options of filling that position. So your job is always simple. In how many ways can I complete this position? Now, after I've replaced 1 kid here, I'll be left with 5 kids. And then I'll be left with 4 kids, and then I'll be left with 3 kids, and I'll be left with 2 kids, and then the last kid will have to sit right at the end. The solution of which is just 7 factorial. So this is actually going to be 7 factorial ways. Those are 7 factorial ways that you can possibly put these kids here to sit if you don't have any restrictions in terms of who sits where. Of course, you can't repeat a person. If you have Lwazi sitting in a particular position, you can't have Lwazi sitting here and there at the same time. That's why the numbers keep decreasing by 1, because you're losing a kid in a particular position at all times. So you always have 1 kid less to decide who you are putting in the next seat. All right. The next question is pretty basic and interesting because it's really, really involved. It says to us here, in your second photo, Lwazi and Ngwenga can only sit on their 3rd and 4th seat. So either way, what is the probability that the last seat is occupied by a boy and only a girl can sit on the 4th seat? Interesting. Okay. So now remember, we're looking for the probability that this particular case is seen. So I'm going to say the probability of this case is going to be equal to, remember that the probability is always going to be the total number of the times that we get the event of interest divided by the total number of the sample space. So we are looking for all possible outcomes related to what we want versus all possible outcomes. Okay? So these are the 2 things that we need to try and figure out what the probability value is going to be. How many of these arrangements will include what they are interested in, such that Lwazi and Ngwenga sit on the 3rd and the 5th seat, and we have a boy occupying the last seat. The last seat must be a boy, and girl to sit on the 4th seat. So all these conditions, we need them. How many of our arrangements will be set up in that fashion? And lastly, what is the total possible outcomes if we just have Lwazi and Ngwenga in those positions that we want them to be on? So let me start first of all by the total number of the sample space. That is why we always say counting principle is not probability. Counting principle is a method of counting possible ways of doing something. Once you start dividing by the total outcome, you start now talking about the probability. So let's find those 2 values of our ratio on the right-hand side of our equation. So the number of the total sample space is going to be 1, 2, 3, 4, 5, 6, 7. So those are the possible seats that I have. I have seats in total. What do we know? We know that we're going to put Lwazi or decide either way, Lwazi or Ngwenga on the 3rd and the 5th seat. So 1, 2, 3. So here on the 3rd seat, you can have Lwazi or you can have Ngwenga. For 5 on the 5th seat, you can have Lwazi or you can have Ngwenga, depending on who sat first. You can obviously have either one of them in those 2 positions. So now there's 2 of them. There's 2 of those kids. So let me start by them. You always start with the conditions that the examiner gives you. Now the number of possible outcomes I can have in this seat is 2. I can either put Lwazi or Ngwenga to sit in that position. If I decide that I want Lwazi to sit there, it means Lwazi is no longer available for choice when I'm moving forward. That means I'm left with one of them to occupy the second position, right? So those are very important to keep in mind. My decision for who sits here can be done in 2 different ways because there's 2 of them. But if one of them sits, then I'm left with one of them to occupy the next position. Be careful of that. Now that means out of the kids that I have, which is 7, I have already placed 2 of them. How many kids are left out of 7? I'm now left with 5 and then 4 kids. And then I'll have 3 kids here, and then I'll have 2 kids to decide, and then on the last kid will sit there at the end. So that's the answer that I'm getting there. And when you start finding the product of those 2, you're just trying to figure out the product that you get when you multiply 5 and 4 and 2 and 3, and you multiply it with 1 and 2, you're going to end up, of course, with 240 possible ways of sitting these kids. So you can sit them in 240 possible ways without having any challenges. Do make sure that you understand what that is actually all about. So don't make mistakes. Make sure that you understand what is going on. In fact, that is the total number of the sample space. We're now interested in the total number of the event of interest. The cases where certain people sit in certain positions, 1, 2, 3, 4, 5, 6, 7. Always set yourself up for 7 possible outcomes, and let's see what is going to actually happen. Now, what are the restrictions that we were given? Remember, we still want Lwazi and Ngwenga in those positions that we arranged, we spoke about. Here, it can be Lwazi or Ngwenga. Here, it can be Lwazi or Ngwenga. One of them is going to sit there. They said they want a boy to be at the end. Remember, how many boys do we have? We've got 3 of them in total in the remaining list of kids. And then they said the 5th position must be occupied by a girl. I think they said the 4th. Yeah, the 4th can be a girl. So here, we can have a girl. So because here we can have any girl, and remember in our list of girls, we were told that there's 2 girls that we have in our list. And that information is in the opening statement. 3 boys, and we've got 2 girls right there on top, underlined in yellow. Okay, so let's go back and see what is the answer going to be. So let's start with the restrictions. Start with the Lwazi and Ngwenga situation. I can sit any of the 2 here. If I sit one of them there, that means the remaining of those kids will obviously have to sit here. So I've sorted Lwazi and Ngwenga. Let's go to the boys. How many boys do I have? I've got 3 boys. So I can put one of those 3. So this position at the end can be filled by 3 possible cases. It can be one of them. And then for the girls, like we said, we're left with only 2 girls, so this position can be filled in 2 different ways. Those numbers that tell you that they just tell you how many ways can you do something. I've accounted for 4 kids in total out of 7. That means I'm left with 3 kids to decide who comes here. I'm left with 2 kids to decide who comes here. And then I'll be left with 1 kid to position there. And the total number of ways in which you can do this is just going to be that awesome product that you see there. The product of 3, 2 and 2 and 2 is 8. So we're just looking at the product of 8 and 9. And I promise you 8 and 9 is going to give you a number 72. So those are the possible outcomes that will have this arrangement of interest in place. Now that means the probability is then going to be that 72 that you have divided by the 240 that we have there. And you can obviously try and convert that to a decimal. If you go back and you call your fraction part in, you ask it what is the ratio of 72 and 240, backspace. All right, you're going to end up with an awesome question that gives you 0.3, which is just an answer that is 0.3, aka 30%, if you want to write these things as percentages. A very awesome question that is absolutely based on probability and counting principle. You really need to learn how to work out the values there. That 30% tells you the number of possible outcomes are 72, but the probability that you will achieve that outcome is going to be 30%. That means you're achieving this required or desired outcome once in every 3 chances. An absolutely awesome show on probability and counting principle. It's basic. I'm one person who hates using formulas, and I encourage you to also learn this process of lining them up and filling the restrictions first. On a show that is proudly brought to you by Liberty, thank you very much for being part of this show. We're going to see you again next time. A big shout out goes out to you for being with us. Another big shout out also goes out to the production team for helping us to set this up. From me, until we meet again next time, bye-bye.